Welcome back to Module 4, Lesson 14. Today we're going to look at computing the actual length from a scale drawing. Okay, so let's jump right in here in example number 1. The distance around the entire small boat is 28.4 units. The large figure is a scale drawing of the smaller drawing of the boat. State the scale factor as a percent and then use the scale factor to find the distance around the scale drawing. Okay, so here's what we're saying. We're saying that this is our actual drawing and this is our scale. Okay, if we think about, let's do scale factor first because we need that to help us solve the problem. So if we're looking at, and remember we're going back here to horizontal and distance and vertical distance. So if we look at our small boat first, our horizontal distance, I'm going to put HD, horizontal distance, is here. I'm going to put dots in there. 1, 2, 3, 4, 5, 6, 7, 8. Our horizontal distance is 8 units. Our vertical distance of what we need is the vertical distance of the little sailboat part. Right, so that's this 1, 2, 3, 4, 5, 6 units. Now let's look at our large boat. Okay, our horizontal distance for this one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So that's 22 units. And our vertical distance is, there's a little bit there, maybe half of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then we've got like half of one, so we're going to call that 16.5 units. All right, so now we have our scales, right? Now we need to figure out, well, what is the scale the percentage, right? So if we take our scale drawing, remember, and divide it by the actual, so that would be 22 divided by 8, because it's the horizontal distance divided by the horizontal distance of the smaller one. 22 divided by 8, let's see what that is. $2.75 or 275%, right? Let's double check and let's do the same thing for the vertical distance. So that would be 16.5 divided by 6. Let's put that in the calculator. Also 2.75. All right. So 2.75 or 275%. All right, now we're cooking. Now we can find out what is the distance of the distance around. So we're going to call that DA, distance around. And we can take now 2.75 and multiply it by 28.4. 28.4, remember, is the size of the smaller boat, the distance around that. So if we take these two numbers and we multiply them together, so 2.75 times 28.4, we get 78.1 is the distance around the scale, oops, not the sail drawing, but the scale drawing, aka large boat. All right, awesome. Let's go to the next one. Exercise number 1. So in this one, the length of the longer path is 32.4 units. The shorter path is a scale drawing of the longer path. Find the length of the shorter path and explain how you arrived. All right, so again, the first thing we need is the scale factor. So for this one, this is a little bit more of a challenging image. And so we're going to use just the horizontal distance. And this is large path first. And we're going to use this one right here. 1, 2, 3, 4, 5, 6. So this is 6. 6 units. The smaller one is 1, 2. Oops, sorry. So 2. Now remember, in order to find out, because this is the scale drawing and this is the actual. So in order to find it out, we need to divide. So we're going to take 2 over 6, which gives me, what, 1/3, which is 33.1% if you don't know. It's a pretty popular repeating decimal. So that's 33 1/3. Great. Now we can find the length of the shorter path with this information. Because we know that the original is 32.4. We're going to take that. We're not going to multiply it by 33 1/3%. We're going to multiply it by 1/3, right? That's easier. Which gives us 32.4 divided by 3. And let's put that in the calculator. 32.4 divided by 3 equals 10.8. So 10.8 units. 10.8 units is the length of the short path. All right, please make sure to write down any questions. Otherwise, let's go on to the next one. Example number 2. In this example, Sherry has designed her garden as shown in the diagram above. The distance between any 2 consecutive vertical grid lines is 1 foot. The distance between any 2 consecutive horizontal grid lines is also 1 foot. Therefore, each grid square has an area of 1 square foot. After designing the garden, Sherry decided to actually build the garden 75% of the size represented in the diagram. What are the outside dimensions shown in the blueprint? All right, well, the outside dimensions we're talking about here, right? Corn, where corn is and where tomatoes is. So 1, 2, oh, my pen went out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 5, 6. All right, so this is 26. We're going to write that down. So the length is equal to 26 boxes, right? But remember that they're each 1 foot, so that's 26 feet. All right, and now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12 over here. So the width is equal to 12 boxes, which is equal to 12 feet. Excellent. All right, what will the overall dimensions be in the actual garden? Write an equation to find the dimension. How does the problem relate to the scale factor? Okay, so for this one, we're looking at a 75% reduction. This is what we want to look at, okay? So if the length is equal to 26 feet, oh, I don't know what was going on right there. 26 feet, we're going to multiply that by 0.75. 19.5 feet. And then the width is 12 feet times 0.75 is 9 feet. So the dimensions are going to be 19.5 feet by 9 feet. Right? Those are just the outside dimensions. So what if Sherry plans to use a wire fence to divide each section of the garden? How much fence does she need? Well, let's think about our image here. She's going to need one along the top and the bottom of the garden, and that's 26 times 4. Why 4? Because we've got this outside one, but then we have this one right here that's also 26, right? So we have 4 of those. All right. Then we have our 12. Now 12, we've only got one on each side. So we're going to take that plus 12 times 2. All right. Then let's see what else do we have here. We've got these inside, right? We've got these things here, right? Let's see what those are. 1, 2, 3, 4. And there's a little bit at the top. So we're going to call these 4.5. And there are 4 of them. So we're going to take 4.5. We're going to add 4.5 times 4. And then the last one we have, what are we missing here? Oh, this center one right here. Right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, that one measures 14, so we're going to add 14. Let's break this down. Let's see, 26 divided by 4, that's 4 and 2. 104 plus 24 plus, let's see, 4 by 18 plus 14. If we add all these together, we get 128, 138, 160 feet. Now, this is, we're not done yet, right? Because that's the drawing. But remember, her actual was a 75% reduction. So we have to come in here and take 160 feet, multiply it by 75%. Is 120. So she will need 120 feet of fence for the garden. All right, let's look at the next one. It says, if the fence costs $3.25 per foot plus 7% sales tax, how much is the fence going to cost? Well, it's $3.25 per foot, and we have 120 feet. And then our sales tax, remember our sales tax is an increase. So it's 100% plus 7%, which is 107%, okay? So we can multiply that by 1.07. And if we put that all into our calculator, because remember, we can do it at the same time. 3.25 times 120 times 1.07 is equal to 400. So this is $417.30, but it's 30 cents. So $417.30 is the total cost of the fence. All right. Again, don't forget to write down any questions you have. Let's go ahead and go on to example number 3. In example number 3, we've got race car number 2 is a scale drawing of race car number 1. The measurement from the front of race car number 1 to the back of race car number 2, of number 1 is 12 feet. While the measurement from the front of race car number 2 to the back of race car 2 is 39 feet. If the height of race car 1 is 4 feet, find the scale factor and write an equation to find the height of race car 2. So again, we have this information, right? We know what the length is. We have 4 feet for drawing 1, but we're looking for what the height is for drawing 2. That's what we're trying to find out. So to start out with, we need to find out, well, what is our percentage? What is our increase? And remember, the way that we do that is, in this case, we're going to take the larger, right, which is our drawing 2. So let's call that drawing 2 equal to the percentage of drawing number 1. Okay, so drawing number 2, if we take 39, right, that's what we need. And then from drawing 1, this is 12. If we divide both sides by 12, we get 39 twelfths, or let's see what that is in the calculator. 39 divided by 12 is 3.25. So this is P equal to 3.25, or a 325% increase, right? That's what that means. So now, because we know the height of drawing number 1 is 4 feet, we can actually just take 4 and multiply it by 3.25. And we get 13. And so what does that mean? That means that the height of number 2 is 13 feet. All right, and there you have it. Let's look at exercise 2. Feel free at any time to stop if you want to stop for exercise 2 and 3 and give it a try. See if you can come out with the correct answer and then come back and check. That would be great. To determine the scale factor and write an equation that relates the height of side A in drawing 1 and the height of side B in drawing 2 to the scale factor. The height of side A is 1.1 centimeters. Explain how the equation illustrates the relationship. All right, so what we're looking for is we're trying to figure out the percentage, because we have to do that before we can figure anything out, okay? So what do we have? I have this horizontal distance here, and what I'm looking for is this vertical distance right here, okay? So to figure out the scale factor, we are going to take drawing 2. So let's do drawing 2. I'm just going to write it so you can see what we're doing here. Multiplied by the percent of drawing 1. So drawing 2 is 3.3 centimeters, okay, equal to the percent, and then we're going to multiply that by 2. Okay, so divide both sides by 2. 3.3 divided by 2, I feel like I should be able to do that in my head, but I can't right now. 1.65, or 165% increase, right? That's what that means. So now we're going to take that information, and now we can find the height of B. Okay? 1.1 centimeters times 1.65. And if we put that in our calculator, 1.1 times 1.65, 1.815. And this is centimeters, okay? So this is the height of B. And there you have it. Exercise 3. The length of a rectangular picture is 8 inches. The picture is to be reduced by 45.5% of the original, right, picture. Write an equation that relates the length of the picture and explain how it illustrates. Well, if the length of the picture is 8 inches and it's a reduction of 45, then we're just taking those two and multiplying them together. Now, 45.5% can be changed to 0.455. Okay, and that's what we're going to multiply by. So if we multiply this, it tells us that the other picture, the original picture, so 8 times 3.64 inches is the length of